Alright, everybody, today we are dealing with what's called rational exponents. Now, properties of exponents. I'm going to zoom out a little bit. Here's all the properties of exponents. If you wanted to, you could pause the video right now and copy all of this down. But I'm sure you don't want to do that right now because you've already done that. So right now we're going to focus on how to use them. Ooh, problem number 8 is a good problem because it requires problem number 8.
Okay.
Requires some thinking. So listen up. This right here, everybody, is a power. This is a power. This is a power. And even though you can't see it, there's a cute little number 1 right there, 4 raised to the power of 1. That is also a power. What we're going to be doing right now is called a power of a power. Now, if you don't know what a power of a power means, it means if you have a number called a raised to the power of n, and then you take that and raise it to another exponent, you are allowed to take those two right there and do what with them? No, don't listen to that. You're allowed to multiply these together. What? Yes. I'm serious. And this becomes a to the power of n times n.
How do you multiply and just add that?
Alright, here we go. Here is the most commonly confused. Ready? I'm going to go x squared times x cubed, which is x to the power of 5. This is not the power property. This is called the product property. But if I take x squared and I take that and raise it to the power of 3. That's right, Alyssa. That's x. I'm sorry, Marley. I'll try to do a better job of saying your name, Marley.
Basically like 2 times 3. So it's like 2 times 3.
That's right.
Yeah.
You can be taught.
Thank you.
Yay. That's from Aladdin. Robin Williams. He was the genie. That's right. He can be taught.
I think it's funny because the people watching this video are going to hear talking about stuff during the break.
That's why I try not to do videos in this class very often. Usually it's my 3rd period class, which is a lot more dependable and responsible.
But because there's like, what, 3 people in there?
Oh, did I say that out loud? I'm sorry. Alright, so, everybody, we have a power to a power. So could you please, what is a half of 2? So a negative half would be a 1. So write that down, please. Shh. I got a whole 5 seconds. Shh. Your name on it. Shh. Alright, so right now, we're doing a power to another what? What's a negative half times a negative? Alright, the first. This is the one that's going to be totally confusing to some of you, but not all of you. That's right, 4 to the power of negative.
What?
Wait, negative 1 half times 1.
Stands to 1.
Yes.
So everybody, we just did what's called a power of a power. Now we're not done. You know you're not done. Here's why you know you're not done. Because you're not allowed to have negative exponents. That's not okay. Well, I'm trying to talk over Noah. It's very difficult.
Are you using a pen now?
Yes, I am.
Why?
On my turn.
So right now,
I can't see the pencil. No.
where's your pencil that you're going to use? One of the most misunderstood concepts is the idea of the negative exponent. We're going to talk about what the negative exponent means. If I have any number and I raise it to say a power of negative 1, that means 1 over a to the first. Now, an easy way to make a negative exponent positive is either just to shift it above or below the fraction sign. So if I wanted to make this right here positive, I can grab it and I can just take it and move it down and it becomes positive. So right here in the denominator, I want you to understand, I'm going to have an x and a y. I'm not moving the y because that exponent is already positive. You guys see how this exponent right here is negative? So I'm going to move this up. So make this 4 to the power of 1/2. guys to understand right now is we have 4 to the power of 1 half. This is what you guys don't understand about this.
Isn't that 2?
It is 2. Because 4 to the power of 1 half is the same thing as saying the square root of 4. Now you don't notice this, but that right there, that index for this radical is a 2. And that power to the 4 is a 1. So I want you to look at a pattern here. This is something you need to have in your journal. If I have a number raised to a fraction called a rational exponent, that's going to be the same as that same number inside of a radical, where n represents what's called the index, and m is whatever power goes to that particular number. This is a pattern you need to have memorized or in your journal. Okay?
Yeah.
That's why this right here, everybody, becomes 2 over x times y. Now, this right here will be your answer. Now, there's something we haven't quite done yet to complete it. And this is the part that's another difficult concept to teach. If you have a radical, all right, and let's say I have x squared and I have y to the 4. Even though you can't see it, that's an index of 2. So that index controls what comes out. Right now I'm looking for groups of 2. Now, how many groups of 2 come out right here? Just 1, right? Because what does this break down to? An x times an x. So when the x comes out, y, that's basically y times y times y times y. So how many groups come out? 2. So it becomes a y squared. But whenever you have an even index, and there's an odd number that comes out for the exponent, in order to make sure that your answer stays positive, you must place absolute value bars around them to make sure that your answer is positive. Right now, can I plug in any positive or negative number in here and the answer is always going to be positive? Here, this is x to the first. This is y to the first. Were we dealing with the square root? Were we dealing with the square root? We were, because we were dealing with the power of what? Power of 1 half. So the index is what? Not odd, it's even. So the final answer for this particular problem, you must place absolute value bars in order to make sure that your answer is positive. Now, look at the hand. Right here. Not talk to it, but look at it. Any number you plug in here now, whether it's negative or positive, is going to be a positive answer, because what do the absolute value bars ensure? That everything's
Okay. Do we put individual in?
Yes. Okay. It's the individual absolute value of x and the individual absolute value of y that we have to use. Now we're going to go to some more problems. We're going to be using absolute value bars. When do we use them? When do we don't?
Even index usually.
Yeah. Oh, hey. Is this even or odd?
That's odd.
That's an odd index. So check this out. You're going to write 64 raised to the power of 1/3. X raised to the power of 6 over 3. What I just did was called a power of a power. Maybe you don't see it. There's a 64 to the power of 1. Now, one of these is very easy to simplify. Which one's the easy?
Probably x. I don't actually.
What's 6 divided by 3? Boom.
That's x squared. And 64, so the cube root is 64. So what times what times what would be 64?
Right, what times what is 64? 4. Right. So the cubic root, or 64 raised to the power of 1/3, is the number 4. For those of you who aren't good with your powers, 4 to the 0 is 1. 4 to the first is 4. 4 squared is 16. 4 cubed, which is 4 times 4 times 4, is 64. So I want you guys to think about it this way. Watch. I'm going to change the number 64 to 4 to the power of 3. Now, 4 to the power of 3 is raised to the power of 1/3. What can I do with those powers?
You multiply.
And what is 3 times a third? This becomes 4 to the first. I don't have to say 4 to the first, because everybody, this would be your final answer for number 9. Why don't we have to worry about absolute value bars? Because our index was not odd. Sorry, not even. The index was odd. All right, so moving on. Number 10. Okay. Ooh. Index, everybody. What's our index right here? Ooh, that's even, right? All right, so, everybody, here's what we're going to do. You're going to apply a half to every single number. So here's what I want you to put. 5 to the power of a half.
Now the square root, the same thing as the square root of 5?
Yes. X to the power of 6 over 2. Jordan, I've got to control that log a little bit.
My hat's left
All right, so right now, this is what we have. We have 5 raised to the power of a half. X raised to the power of 6 over 2. Y, 4 over 2. We just did what? What property?
Product of the power of a,
No.
the power of a,
Power of a power. Okay? And that's why we multiply. Now, everybody, we have an even index, don't we? So right here, if this becomes x to the power of 3, or x cubed, in order to make sure that our answer stays positive, I must place absolute value bars right there. This is y squared. I don't have to put absolute value bars because any number that gets plugged in for y, if you square a negative, it becomes positive no matter what. So you don't have to have the absolute value bars for that guy. So this right here is 5 to the power of 1/2. Now, everybody, this is your answer. Or, listen, if you were to write it in radical form, by the way, everybody, this is what's called rational exponent form. So right here, I'm going to write rational exponent form. I'm not going to write the word form, but that's rational exponent form. Here's everything right now. I'm going to write it in radical form. Here we go. You still have x cubed with absolute value bars. You still have y squared. But then you would just write a radical 5. This would be your answer in radical. Because 5 to the power of 1/2 is the same as the square root of 5. It's kind of hard to see because that's a 1 and a 2, and usually you don't write a 2 there, and you don't write a 1 there.
So we have to put the 1 in the little,
This is just part of the screenshot, unfortunately.
Say if it was 5x to the 12th power.
5, 6, hold on, say it. 5,
5x to the 12th power.
5, oh wait, 5x to the power of 12.
So you were putting you were applying the
What index?
1 or 2.
Okay, so basically 2.
Not the.
Alright. Like this whole thing right here.
So 1 over 2. You wouldn't have to put absolute value on it, would you? Because you simplify from even to an even, and you wouldn't.
Now, this right here is basically what I just did. This would be 5 to the 1/2. This would be x
to the 6.
You wouldn't have to put absolute value bars because that's even, but that's
staying.
staying.
Okay. Just follow the transform. All right.
So the answer would be x to the 6th radical 5. Or this. Alright, everybody, right now I want you guys to place all of these variables underneath one radical, if you would please. I've got x squared. I've got y cubed. I've got x cubed. I have y to the 4th. Even though you can't see it, what number's going to go right there?
1.
No!
I mean 2.
Yes. I apologize for whoever has to listen to this. By the way, if you're listening to this right now, there are plenty of other places to go on YouTube where it's not as ridiculous as this.
Why are you looking at me?
Because I just happen to turn your way.
Okay.
Now,
People might die unless you.
yeah, everybody likes this. No, I doubt it. Right now, I have 24 subscribers. After this video, video, I'll probably be down to 12. Alright?
I'll make sure I go on subscribe.
Mr. Dude, I'm great.
You are. You're fabulous.
Yeah, so everyone is gonna be happy to hear me talk.
They're actually happy to hear you eating chips.
You're right.
That's what they're happy about. They're like, you know what? I need to get me a bag of chips.
That was
So,
one thing.
because you are all that. And a bag of chips. There you go. Now, I have x squared, I have x cubed. How many total x's do I have being multiplied to each other?
2.
Oh my God. 5 X's.
I thought you meant like literal X's.
By the way, x squared
It's 2
is x times x.
And there's 3
X
of these.
cubed is x times x times x. You have a total of x to the power of 5. Now, using the same concept without having to make me write all of these, we have a total of 7 y's being multiplied.
I'm so naughty. Thank you.
Now, everybody, even though you can't see it, that index is a 2, which means you need to look for groups of 2. So, groups of 2. You could hold on the whole chip eating over there.
This root can equal out 2 X's and 1 X, so like equal out X.
Yeah, so listen, I have 1, bless you, 2, 3, 4, 5. Just pretend there's a whole bunch of little dots right in between, okay?
We
Got
got
a couple of what? A couple of pairs, right?
You got 2 pairs.
So I have an x squared that comes out, and I have 1, 2, 3, 4, 5, 6, 7. If I do these problems, I don't do this, but since I'm trying to teach people how to do it, I write the extra
There's
stuff.
gonna be 3.
Y cubed. Very good.
So we X.
What's still left inside?
The X and the Y.
Very good. Now, we had an even index. That means something is going to require absolute value bars. Miranda, it is the y because it says y cubed. Very good. Good job, Miranda. Everybody, let's give Miranda a little round of applause. All right. The reason we did that is to make Alyssa and Harley jealous.
It worked.
All right.
These people are probably like, what school did they go to?
Last problem we're going to do, and then you're going to be responsible to do things on your own, is problem number 12. Problem number 12. Once again, everybody, in problem number 12, we have what's called a power of a power. Victoria, because I know you're going to get this answer right, could you please tell me what's going to be right up here, Victoria? That's right, p to the power of 2a. Now, Victoria, that's a little too much. I need you to do it more basic, please. Could you tell me what's the first fraction before I simplify it to 2a? 6a over 3, which becomes, now I will call on you, Marley, 1 second. 1 second. Let me erase this real quick. Moving a little further. There we go. This right here, I'm going to put p to the power of 2a. Alyssa and only Alyssa, could you please apply the power of 1/3 to the negative 3a? What do you get?
So like it would be p negative 3a over 3.
That is absolutely
Wait,
correct.
I'm not finished.
Good.
The next one would be p negative 1.
That's right. Now, let's just give her a round of applause. Okay. Now we are almost done. We're so close to the finish line. It's like these P's right here are like getting ready to graduate high school. They're so close. Let's not quit the problem right now. All right? Let's not quit it. Let's just go ahead and finish and graduate. Why don't we?
Let's not swim back to the
Let's not just say, we're done.
We're swimming back.
We're going to go. Now, everybody, could you please write the word quotient property? Now, if you don't know what the quotient property is, shame on you. But if you don't know it, here it is.
You subtract.
Oh,
that's right. I'm so sorry.
So this becomes a to the m minus n. So everybody, make a little arrow down here. Here we go. E to the 2a. By the way, minus a negative a. Uh-oh.
Plus
So
a.
negative 3a.
That's right, Marley! round of applause. So, everybody, the final answer to this particular question, P to the power of?
2A.
No, 3A.
That's right, 3A. That's right. She can.
Yes.
Have a wonderful day. Please, don't tell your friends.
Have a wonderful